All right, let's get into it. You've probably seen those beginner tutorials, right? The hello world of AI. Well, today we're going way beyond that. We're going to break down what it actually takes to build a pro-level computer vision model. We're talking about something that can watch real-time video, say on a factory floor to keep people safe, and perform at an incredibly high level.
And that right there is the key. Most guides show you how to get maybe 85% accuracy on some perfect, clean little data set, and they call it a day. But that's just not the real world, is it? This explainer is different. We're going to focus on the messy, challenging, but totally achievable journey of pushing past 95% accuracy for a system you can actually put to work.
So here's our game plan. First, we'll get a handle on the core tech, YOLO. Then, we're going to talk about the single biggest decision you have to make. After that, we dive deep into the three things that really separate the pros from the amateurs: your data, how you label it, and then the final steps to really dial in that elite-level performance.
Okay, let's jump in. So, to build a system that can watch video and actually understand what it's seeing, you need a seriously powerful tool. And in the AI world today, that tool is, almost without question, YOLO.
YOLO stands for You Only Look Once, and honestly, the name just nails it. It perfectly describes its genius. See, instead of analyzing an image in a bunch of different steps, it takes in the entire frame and figures everything out in one single shot. And that is what makes it such a game changer.
Now, what's really mind-blowing here is the massive leap in performance. The old way of doing things was this two-step process, and it was slow, like 7 frames per second slow. That's basically useless for live video. But YOLO, it turns the whole thing into one single problem, predicting the boxes and what's in them all at once. The result? Modern versions can chew through over 200 frames per second. That's the difference between a slideshow and flawlessly monitoring a busy factory in real time.
All right, so we've got our tool. Now we're at a crossroads. And this is probably the biggest strategic call you're going to make on your entire project. Before you write a single line of code, you have to decide, are you going to build your AI from the ground up, or are you going to fine-tune a model that already exists? And this comparison really lays it all out, doesn't it? Training from scratch is just a colossal undertaking. You need an insane amount of data. We're talking 50,000 plus images for every single object you want to find. And it can tie up expensive GPUs for weeks. Fine-tuning, though, that's where you start with a model that already knows what edges and shapes and colors are. You just have to teach it your specific things, which takes way less data and can be done in just a few hours.
So here's the bottom line, and it's super simple. Unless you're a massive tech company with unlimited resources working on a totally unique problem, you're going to fine-tune. It's just faster, it's cheaper, and it's way more effective for pretty much every real-world application you can think of.
Okay, now we're getting to the absolute heart of it all. You can have the best AI model, the fastest computers, but your whole project will completely fall apart if you mess up this next part, your data. It isn't just important, it is everything.
And this right here, this is the golden rule of data collection. It's not about who has the most images. It's about who has the right images. Seriously, 1,000 photos of the exact same person from the same angle is way less valuable than, say, 300 photos that show a huge variety of different situations.
So what does diversity actually mean for our factory safety example? It means you have to capture video footage that looks exactly like what the model will see when it's live. You need video from the day shift and the night shift. You need workers up close to the camera and way in the back. You need to see them head-on, from the side, even partially hidden behind a machine. Why? Because if you don't show it to the model, it can't possibly learn it.
So is there a magic number? Well, it always depends, but a really solid target for getting professional results is somewhere around 1,500 unique, diverse, and, this is key, perfectly labeled images for each and every class you want to detect. That's the real foundation for breaking through that 95% accuracy barrier. We just mentioned labeling, or annotation. This is where you, or someone on your team, manually draws boxes around all the objects in your images. It might sound a bit tedious, but let me tell you, this one step sets the absolute maximum performance your model can ever achieve. And I really want to hammer this point home. This is not a metaphor or some catchy saying. It's a hard limit. If your annotations, the boxes you draw, are sloppy, your model's going to be sloppy. Period. If the people doing the labeling are only 90% accurate, you could have the most expensive, powerful AI in the world, and it will never get past 90%. It's literally garbage in, garbage out.
So, how do you make sure your annotations are top-notch? You need strict rules.
Rule 1, boxes have to be tight, right up against the edge of the object. Rule 2, you have to label every single time the object appears. If you miss one person, you're accidentally teaching the model that that person is just part of the background. And finally, you've got to have clear guidelines for all the tricky stuff, like people who are partially blocked or objects that are super tiny and far away.
Okay, you've made the smart choice to fine-tune, you've gathered a really diverse data set, and you've labeled it perfectly. You trained your first model, and it's pretty good. Maybe it's at 85 or 90%. Awesome. Now the real work begins. This is the final push to get it ready for the real world.
And this part is super important. Getting from good to great isn't magic. It's a step-by-step process, and you have to do it in this order. First things first, go back and fix your annotations. Seriously, it's the single biggest lever you can pull. Then, step 2, you hunt down the weak spots in your data's diversity, and you fill those gaps. Only then, after you've done all that, do you even think about messing with the technical stuff. This chart just says it all, doesn't it? Just look at those huge jumps in accuracy you get from the first 2 steps. Fixing your labels and improving your data, that's where the lion's share of your improvement is going to come from. All the algorithm tweaking later on, that's just the final polish. The real work is always in the data.
And hey, when we keep saying accuracy, what the pros are really talking about is a metric called MAP, or mean average precision. It's basically a combined score that measures how well the model found the object and if it knew what that object was. So when we're aiming for a 0.95 MAP, we're saying we want to be 95% correct on both where the box is and what's in it.
All right, let's wrap this up with the 4 unbreakable rules for building a professional-grade vision AI. Number 1, always fine-tune. 2, obsess over data diversity, not just data volume. 3, remember that your annotation quality creates a hard ceiling on your model's performance. And finally, number 4, improving your model is a system, not magic. You start with the data, not with the code. You know, this whole process isn't just for factory safety. You can apply it to retail, to medicine, to agriculture. Pretty much anywhere you need a machine to see and understand the world through a camera. The fundamentals are always the same. So, the only real question left is, what problem would you solve first?